Good morning, good afternoon, good evening, folks. Today is slope. We are talking about slope. When I think slope, I think of a hill. And when I think of a hill, I think of the steepness of that hill, or however steep that hill is. So it's only fitting, folks, that slope is defined as the steepness of a line. Okay? The slope is just a measure of how steep a line is. It's the ratio of the rise to the run. In other words, our slope is always going to be found by taking our vertical change and dividing it by our horizontal change. Okay? You might not always see slope. It has a couple synonyms. Typically, we represent slope with the letter M. And we often say, hey, slope is rise over run, because that's an easy way to remember it. But a couple other things you might see that you should be familiar with are, and they all mean the same thing. Everything that I'm writing here means the exact same thing. So rise over run is the same thing as a change in y divided by a change in x. You might not see that for a year or two, but might as well introduce you to it now. And guess what? Formula we talked about a couple days ago, this is actually how you find the slope of a line. You use our formula y2 minus y1 divided by x2 minus x1. I told you we were going to be using it, so here you go. Okay, all of these things are synonymous. That means they mean the same thing. But if you can remember that slope is rise over run, and if you can remember this formula right here, those are the two most important things of the day. Okay? So by the end of today, we're hopefully going to be able to say, I can find the slope of a line in two different ways. By counting, which means by using our rise over run method, and by using our slope formula. That's this guy. Okay, that's our goal for today, to be able to do that. Now, let's just, quick side note. Slope does represent a constant rate of change. Okay, it stays the same no matter what 2 points you pick on that line to help you find your slope. Slope is always a constant rate of change. Now you'll see what I mean in a few minutes here. So first example, pretty easy one. Find the slope of a hill that rises 30 feet for every horizontal change of 1,500 feet. Well, it kind of words it there for you just perfectly. A hill that rises 30 feet for every horizontal, that means horizontal change of 1,500 feet, that means how much you're running. So it's very easy to find your slope of this hill. All you do is say, hey, 30 is my rise, and I'm running. We say run because we talk about flat ground running. Horizontal is just sideways, right? That's our run right there. So our slope is equal to this guy, which we can reduce. If we divide both of these guys by 30, you should end up with a slope of 1 over 50. M equals 1 over 50. Please remember that rates are always represented by fractions. So you're always going to see your slope written as a fraction, or almost always going to see it written as a fraction. Okay? So keep that in mind. Now let's move on. For number 2 here, oops, I forgot to put our points on there. So I want to graph at 1, 3, and -2, 0. It says find the slope of each line. Okay, I'm going to pretend that's a straight line, and hopefully you will too. Okay, so there's two ways in which we can find the slope of this line. The first way is to just do our, like we talked about over there, our rise divided by our run. And you're still probably, some of you, wondering what the heck that means. Well, that just means, hey, we've got 2 points. We want to find the steepness of the line between these 2 points. We want to see how steep this line is. So we're going to measure by counting from here. We're going to count up until we're even with this guy up here. So that's, I counted up 3 spots. And then from here I'm going to count over to the right, 1, 2, 3. That's another 3 spots. So my rise was a +3, and then I ran a +3. So my rise over my run, or my slope, is actually going to be a +1. 1. This is the rare instance where you'll not see your slope written as a fraction, is when it's a whole number, okay? But you could also write this as 1 over 1. Now, the other way, hopefully you guys might remember, in order to find the slope between 2 points is to use your formula. y2 minus y1 over x2 minus x1. Okay, so it's very simple. You have to determine which point is which. So first of all, we need to make sure we know what our points are. That is 1, 3. And here, I'll try and help you out by changing colors. And this guy's negative 2, 0. Right? Okay. So let's go here. And you choose which point is x1, y1, and which point is x2, y2. I'm going to choose this to be x1, y1. And if you remember, those ones don't mean anything except that, hey, this is my first point, and now I'm moving over to my second point. So we're going to call it x2, y2. That only serves to help us plug in the correct values in the right places. So my y2 is 3, so I'm going to plug that in for y2. And my formula says minus, so I'm going to put a minus sign. And y1 happens to be 0. So plug that in for y1. Now you divide it by, what is x2? That is 1 minus, and what is x1? That is negative 2. So you're doing a 1 minus a negative 2. Hopefully you remember that a double negative makes a positive. So let's simplify this. It's 3 over 3, which is, of course, 1. So if you notice, it doesn't matter which method you use, A or B, you're still going to get the exact same answer. So let's pop over to number 3 here. Same thing. Let's find our slope. I'm only going to do one of the methods, okay, just for time's sake. But maybe you should try both of them. Whoops, sorry about that. I'm going to do the counting method. So I'm going to say, in order to find slope, I need to know what is the rise over the run of this line. So if I start with this point right here, I'm going to say, how much am I rising? 1, 2, 3, 4. Actually, I'm falling 4. And since we're falling, we're going to say that's a negative 4 rise. Okay. And then I'm going to say from here, I'm going to count 1, 2, 3, 4, 5, 6. Well, I ran 6. My horizontal change is positive 6. So that is my run. Folks, so my slope right now is negative 4 over 6, but let's simplify that. It should be negative 2 over 3. Okay. Oops. 1, 2, 3, 4, 5. I made a mistake because I counted wrong. So let's do that really quickly. Let's do it again. The run was actually only 5. Okay, because you counted from here. 1, 2, 3, 4, 5. So forgive me, it's still done the same way. I just used the wrong number. So your rise over your run should be negative 4 divided by 5. And that is your slope. Maybe I should, yeah. So that is your slope, negative 4/5. Okay? If you did it the other way, if you prefer this method of plugging in your points, you would have definitely still gotten the same answer. Let's jump down to 4 and 5, and you guys really need to pay close attention on these. These are our special cases. You'll run into these every once in a while, okay? It's important to know how to handle them. So for number 4, if we go by our counting method, let's do the same thing. Okay, to find the slope, we must do rise divided by run. Wow. Okay, so let's start on the left point. What is our rise? We're actually not rising at all, so we're just staying still. Our rise is 0. Our run happens to be 1, 2, 3, 4, 5. What is 0 divided by 5? Well, it happens to be 0. So I know this can get confusing at times, wondering what 0 divided by a number is. It's always going to be 0. So folks, your end result is to say that, hey, my slope is equal to 0. M equals 0. It should be easy to remember because if you're walking on flat ground, you're not going up or down. So you're not going positively climbing up, and you're not going negatively walking down. You're just going, you're walking on a path that has zero steepness. Okay? That is a special case. Anytime you see a horizontal line, that's a terrible horizontal line. But anytime you see a horizontal line, your slope is going to be 0. So really, if you see one, you don't even have to do your calculations here. You can just know, hey, that's flat, my slope is 0. And here, finally, number 5. It's actually kind of the opposite of this guy. Let's do, in order to find the slope, our rise over our run. Okay, let's start. It doesn't matter which point you start with, you'll still get the same answer. And that's the same with all of these. It does not matter which point you start with, you'll still get the same answer. Okay, so let's start with the top point. My rise is a -1, -2, -3, -4, -5. And what is our run? Well, we just dropped 5. I'm already at my point. I'm not actually running. I'm not going left or right at all. So that's 0. Hopefully you guys remember that you cannot divide by 0. Guys, you can't. It's impossible. Okay? So we don't say that we have a slope of 0. Do not say that we have a slope of 0. We label this guy as, we say our slope is undefined. Okay, that is your answer. If you're asked to find the slope and you're dealing with a vertical line, which we have here, your slope is always going to be undefined. So anytime you have a vertical line, you also don't have to make a calculation. You know your slope is always going to be undefined, no matter what. Okay, folks? Hopefully you took away from this what we wanted to. Hopefully you can say right now, or maybe after you watch it for a few more minutes, I can find the slope of a line in 2 different ways. I know the counting method, just say rise over run, and figure out what my rise is, and divide it by my run. And hopefully I can use my slope formula here as well. Those are the goals of the day. Alright, I will see you.